All right, we want to go ahead and wrap up um, this part of the calculation, and we're going to look at how to do mass-to-mass conversions. Now, 5 basic steps that we're going to use. First, we're going to correctly balance the equation. Second, we got to convert it into moles. Third, which is really third and fourth go together, we need to set up our mole ratio. That's going to be the moles you want divided by the moles you have. And then last but not least, you got to convert it back into the unit that you want, which is most likely going to be grams, but we'll have some where we'll use molecules and volume and liters. So let's look at our first example. Now, 6.50 grams of aluminum react with an excess of oxygen. That point where it says excess of oxygen is just saying that there's extra oxygen there. Now, how many grams of aluminum oxide are formed? Because of the fact that we're going between two different compounds, this lets us know this is going to be a stoichiometric calculation. Now, if I can go ahead and change my screen for a moment. This is going to be a 3-step process. Now, it's going to be very similar to what we've done in the past, though, so don't worry. Now, starting at the beginning, we have 6.50 grams of aluminum oxide. No, just aluminum. Okay, great. Of Al. Now, our first step said that we have to correctly balance the equation. That part's done. Now we have to convert the given into moles. So since we started in grams, that means grams of Al has to go to the bottom. Moles Al at the top. That's going to be how many grams are in 1 mole of that compound. So using our periodic table, we find 26.98 grams is involved. Now, the next part says we need to set up our mole ratio. It needs to be moles you want divided by moles you have. The moles I want, according to the question, is going to be aluminum oxide. So I'm supposed to get 2 moles of Al2O3 out of this reaction when I put 4 moles of aluminum in. Now, at the end of this step, I'll have my final answer. My answer will be in moles of aluminum oxide. I need to take it still one step further. So I need to look at it and see, okay, what is my molar mass? Because I need to go to grams, I need to convert this into grams. So I'm going to need my molar mass. So 1 mole of Al2O3 goes to the bottom. And now I need my molar mass. After doing the calculations, I find that it's 101.96 grams Al2O3. Now that I have this information in place, all I need to do is follow my normal pattern and multiply everything on top, multiply everything on the bottom, and then divide them. Once I do this, I'm going to end up with an answer of 12.31, I believe, grams of aluminum oxide. So once I do this calculation, or if I'm given 6.5 grams of aluminum to react with oxygen, I can expect that I should receive a product of 12.31 grams of aluminum oxide. This is just going to be our first step. This is our first problem where we're going to use this. Now, I want to leave one more example with you, and this is the other steps where it's worked out in detail. So if you'd like to pause it to copy down the information, feel free to go ahead and do so. We got our final answer of 12.3 grams are formed. Now, what I want you all to do is take a little bit of time, and I want you to complete this problem. If 10.1 grams of iron are added to a solution of copper 2 sulfate, how many grams of solid copper would form? So you have your given information, you have the product that you're focusing on. Go ahead, use your notes, use the activity that we've just gone through the example, and solve to find out how many grams of copper will be formed. I'll see you tomorrow, and make sure you bring your questions. Have a great evening.